Hi folks, this is the third video segment that I'm doing on explaining how the product engineering optimizer within Catia 5 can be used to solve certain practical problems. Uh, uh, the problem that I would like to do is pretend that I have a wiper blade, which is sweeping an area on the windshield that you can see here. There are some parameters, design parameters, that are going to be changed so that we have the maximum percentage area of the wiped area. Now, because I will not be changing the size of the windshield, this is equivalent to saying that we want to maximize the wiped area, the green area. Let me first show you in the context of three-dimensional problem how this is working, but of course we're not going to be doing it as a mechanism. So this is the situation. Let me change this thing to something other than one, and then we play it. So we have this windshield wiper that is sweeping an area, green area, and we'd like to maximize that area, that green area, by changing the appropriate design parameters. So I'm going to stop this, go back to my transparency, PowerPoint transparency. Okay, so let's go here. Let's talk about this thing. The design parameters are described in this second slide. So we have 6 of them. There are OA, the distance from O to A. This is the wiper arm. There is AB, that's this piece. This is this piece from A to B. Then there is OD, the distance from the center of the revolute arm to the center of the white the windshield. And there is angles alpha. Alpha is the angle of orientation of the blade with respect to the arm, this alpha. And there is angle beta, initial wipe area, and final wipe boundary. Okay, now let me go back here. We also have a constraint. Constraint should be that. We also have a constraint, and the constraint is that the distance from the green area, the white area, to the edge or to the boundary of the windshield should exceed 7 millimeters. Now, for simplicity, I'm going to assume that the windshield is a flat surface, although it doesn't have to be. And I got this idea from a video segment that I saw on a webinar from Rand Corporation, Brand 3D, and the link is here. Except that it's a very good source, except that the details are not presented. So what I'm going to do in this problem is do go through all the steps in order to come up with my answer. Okay, now there are some things that I'm pointing to this third slide. First of all, the length, the size of the wiper blade is fixed. Okay, this is not one of the design parameters. AB is changing, of course. AB is changing, but the actual blade has a fixed length. The other thing is that the wiped area, or the windshield area, which is this rectangle, is also fixed. Okay, the range. These are the design values that I'm going to be using for creating the initial part, and then we're going to let these design variables move or change in these ranges that you see here, and the objective is to find design parameters, design numbers, these dimensions, so that the maximum area is maximum, or percentage what area is maximum. It's the same thing because the rectangle does not change size. And subject is a constraint here. The constraint is that the distance from the boundary of the green area to the boundary of the windshield is should be bigger than 7 millimeters. Okay, so I will leave these here on the side because we're going to be referring to it when I create my model. We're going to do this thing in generative shape design. Okay, so first of all, let's start with a part file right there, and immediately I'm going to save this thing. File, save management, save as on my desktop, new folder, and I'm going to call this thing June 21, 2020. Okay. All right. Now, we know that I'm going to be using several parameters. These are parameters OA, AB, OD, alpha, beta, and gamma. So why don't we actually define these parameters and specify the initial values? And we know how to do that. So we go to f of x, and f of x. We're going to create three parameters of mm, type length. Okay, so first one, I'm going to call this thing OA, and let me see what my design value was, 60, so that's going to be 60 millimeters. Right now, we're just creating these parameters, that's it. Another one is AB, and I believe the initial value is 30 millimeter, 30, oops, 30. Another one is OD. I believe OD was 60, initially 60. Let's double check on that. Yep, right here. And then there's alpha, beta, gamma, which are the angles, okay? So there we are. And now we're going to change this thing to type angle. Initial one is alpha, and the value is 10 degrees. Right? Or new one, beta. I believe beta was 45 degrees. 45 degrees. And gamma, which is 120 degrees. Right now, these are just parameters that I created. That's all. All right, and I'm going to close this. Okay, notice that the parameters appear in my tree. In the event you don't know how to make it appear in the tree, you go to Tools, Options. Just give it a second. Okay, under the infrastructure, here's the infrastructure. Under part infrastructure, select the display and say show me the parameters and any relations or equations that were created. Okay, it's already activated. So my first task is to create that green wiped area. So on the vertical plane, I will sketch. Well, let's do the arm. See this arm? Let's do the arm OA first, okay? Or let's do the blade. How about the blade is from B all the way down here, which is incidentally 70 millimeters. So let me do the blade. So here's the blade. I'll draw it like that right now, right there. Okay, 70 millimeters. 70. Okay. Oops. Yeah, and then there's the arm. So the arm is going to be from a point here to some location there. Okay, and we know that the distance from or the dimension between this point and that point is eventually going, this is going to be AB, and it's going to be, of course, later 30 millimeter when I create my equation. Okay, now let's also put a dimension from point O. This is the point O all the way to the horizontal axis. That's going to be my OD. So from here to there, this eventually is going to be OD, which is 60 millimeters. Okay, and while we're here, might as well make these things the correct value. So this is going to be 10. No, 30, right? 30. Okay, and this is going to be OD is going to be 60. Okay, and yeah, and what else do we have? Okay, let's do the angles now. So we have an angle. What else was there? What else? What other parameter we had? OA, AB, and OD. I did OA. No, I have to do OA now. So OA, which is the length of the arm, this is going to be 60. Okay, so let's do the angle now. This angle, this is going to be eventually alpha, and alpha is right now is 10 degrees. So let's create a dimension between this and that. Right now it's 24 degrees, so that's going to be 10. All right, so that's pretty much it. Now, notice that the point B here that I have on the right side is going to traverse a arc of a circle, because if this is the wiper blade, it's going to end up at a different position, but the distance from B to O is the same as B to O on this side. So that being the case, why don't we do the following? Why don't I go and create an arc of a circle? There's the arc of a circle, with the center being at O, and starts at this top point, and it goes like this. We're going to clean this up in a minute, okay? And then also the point A down below is going to go on a circle. See that? Point A, or not A, this bottom point, which I didn't label it actually, is also going to be an arc of a circle. Okay, so that being the case, let me go ahead and do that. Another from here to there. Okay, good. Now, so the wiper blade eventually is going to be at some, the wiper is going to be eventually at some orientation. Let's do this. So let me do let's do the arm, for example, the arm right there. There are different ways of doing this thing, by the way. What I'm going to do is not the easiest or the best way of doing the problem, but I have to start somewhere, so I'm going to do it like that. Okay, so we're gonna draw a line from here to there. This is going to be the arm. Maybe a better way of doing this thing is draw another circle starting at this point and go like that. Okay, this is going to be a construction entity because I'm going to be using it only to help me draw things. So I'm going to turn that into a construction entity. Okay, so now we'll do this arm. So suppose that the arm in the final position is going to start here. Now I don't want this thing to be construction though. Okay, so the arm is going to be perhaps at this location. We're going to clean this up. Okay, so notice that this was O to A, and this is O to A in the final position. Okay, and then the wiper blade, the blade itself right there, okay, is going to be like so. And we're going to clean this up. for example, from here to to there. Notice that I arranged it so that it went through this point and at some arbitrary location. Now let's do a quick trim to clean this up. I'm going to use the eraser, quick trim. So let's get rid of this piece of the construction one, and this piece is gone. Okay, and now we know that this angle over here is going to be also equal to that. So why don't we try to? I think we're done with this piece. Okay. Now I want some initial and final angles. So in order to do that, I'm going to draw another line down here, which is a construction line. This is it's going to be a construction line. I'm going to turn it to a construction line right now, right there. So the angles, dimension from, see, undo. Okay. See. Oh, there's something there. What's this? Okay. The angle from that line to this line, this is going to be my beta eventually. Right now, initial value of the beta is 45, so might as well do that. There, okay? And another angle that I want is from this horizontal line all the way to that line, okay? This is going to be 120, 120. Good. And finally, this angle is going to be equal to 10, which is actually equal to that. For now, I'm going to make it equal to 10 so that it looks better, but once I create a relation, that actually could have been done later on, 10. 10. The moral of the story is that you must have created this thing that you see there, okay, with the design values that I've given, okay, and I did it. Okay. Now, a few things. For example, this arm that you see here, this arm is going to be a construction entity because eventually I want to put a surface through these four boundaries, these two arcs and these two lines. So I'm going to turn this thing into construction. And I'm going to turn this arm on the final position also to a construction. Okay. Now you have a nice closed curve here that I can actually make it into a surface, fill it as a surface. Now, let's first of all save this. All right, why don't we actually go ahead and create our relationships? For example, I say f of x. Okay, let's move this thing on the side. So this thing, add a formula, equal to rename parameters. This is equal to AB. Now nothing will change because of what I did. This is already the same thing as the thing that I had there. Okay. Okay. There. I want the length of the blade is fixed, so I'm not going to change that. This is the length of the arm. This thing, add a formula equal to OA. Okay. This height, add a formula equal to OD. Nothing changes because of some preliminary work that I did to make sure that these are actually the same values. But all right, this angle, add a formula equal to, I can make it equal to A, or I can make it equal to this angle, but then say that angle is equal to alpha. So that angle, add the formula, equal to alpha. Okay. The angle over, let's see now, this angle is my beta. Add the formula, beta. And finally, the big angle, add the formula, rename parameter gamma. Let's close this. Now, to make sure that actually things are working, let's try it. For example, let me make AB, which AB, 30. AB was where the arm of the wiper blade touches the blade. So if I make this thing let me change, let's make it 55. Notice that it changed, okay? Undo. Let's go and change the angle between the blade, and the arm. So alpha, let's make it 20. You see that? The orientation changed. And what else? As a matter of fact, if you're having a hard time seeing this thing, what I suggest we do the following. Let me undo this. Let's go back to the sketch. Remember, I made the arm construction. Let me turn it back into a line, and the same thing on this side. Let me turn this thing back into arm, back into non-construction, because it's easier to see what happens when you change this. So, see, the arms are shown here. Okay. So, for example, when I changed AB, I changed AB from 30 to 50. What happens is that this length becomes longer. There, you can see that. So it is working. Okay, let's try one more thing. So gamma, let's make it 160. There. Right. The reason that this looks crooked is because I'm looking at it at an angle. Okay, good. Let's put these things back where they were. So this was 120. I believe this was 30. Okay, and everything else is correct. Everything else is design parameter. Now, first of all, let's go and put these things back into construction. So this line, this arm is going to be construction, and this other arm, final position, is also be construction entity. Exit. And the reason I did this because I want to put a surface through that, and in order to put a surface through that, you really have to have a closed curve. Okay, so we are in generative shape design. So there's a fill here. So this thing, and say OK. Notice the surface is put on that. And again, if you look at the view from the front, this is what you've got. Okay, so let's also go ahead and do our windshield. Okay, fill 1 was actually the wiped area. You can see that. Okay, so on that same plane, which was, I believe, the YZ plane, I will sketch. I'm going to sketch a rectangle, centered rectangle. This is where the center of the windshield is, and I said that the dimensions of this windshield are fixed. What is that? 96 by 170. I'm not going to change that. So this is going to be 96, and this is going to be 170. 170. And exit and fill it. Let me change the color of this fill area, the fill one, properties, graphics, change that thing to green. Is that right? So let me look at the other side. There we are. Okay, it's there. So let me look at the front. Okay. Now, if okay, so save everything. What I want to do next is let me change the transparency of this. Okay, there we are, so that you can see what's going on. All right, now, now I will notice that there are sketches here. There is a sketch there. There's a sketch here for the rectangle. I'm going to hide it. And there's another sketch for the wiped area. Hide it. What I would like to do to extract the boundaries of these two surfaces, because at some point I want to say the distance between these two boundaries, I want it to be bigger than some value. Okay, so let's go ahead and do this extract. Extract is in the operations toolbar, extract. So extract, for example, let's do this one. Let's do the green. Actually, I want to fill. Let me cancel this for a second. Okay. So let's go back to fill one. There we are. Okay. I'm going to extract the boundaries of this, and it is extracted. Okay, it's right there. And then I want to go to the next one. Define a work object. Extract the boundaries of this. Cancel. Extract the boundary. There's the boundary, and with point continuity. So extract. So I have extracted two things. This is the boundary of the wiped area. This is the boundary of rectangle. Okay, save everything. Now, I'm going to create two more parameters. One of them is the percentage of the wiped area, and the other one is the distance between the two extractions. So how do we do things like this? So we go to f of x, something of type length. Or let's start with area. Well, first of all, percentage does not have unit. Okay, so why don't we do this thing as a parameter of type real? Okay, and a new parameter. I'll call it the percentage area, and then we're going to say add a formula. Okay, so what you want to do is to take the ratio of the wiped area to the ratio of the windshield multiplied by 100. Now, how do we do this thing? We go and measure. See that? You scroll down, measure between two bodies. Measure area. We want area. What is the area? Area of surface. The area of surface. So you double click on this, and then you go and select the area of the fill one. Okay, fill one was the wiped area. So double click on it, divide it by, once again you go measure area, and now you have to select the area. You select fill two, and then because you're talking about percentage, you multiply by 100. Now We say okay. That's okay. Just say yes, update. So notice what happened right now. That percentage area is 30%. Okay, right there is 30%. Okay, let's do one more, which is the distance between the two extracted boundary, and that distance, of course, is length, length. New parameter. I said distance between boundaries or extractions. Okay, and so we're going to say add a formula, measure distance between two things. See, distance between two things. We can select extract one, and for the second one, in the same argument, second one, extract two. See that? Distance between extract one and extract two, and we say okay. And say update, that's okay, no problem. Right now, there's 2 millimeter distance between these two, right there, 2 millimeters, 2.3 millimeters. Okay, very good. So we say okay, and we save everything. And I want to remind you, those are the parameters, but every time you define an equation, it's a formula, it's going to appear in the tree. Okay, so now we're going to go back to what we're going to go to this, KnowledgeWare and Product Engineering Optimizer. Okay, good. You click on the optimize, and carefully let's look at these things. So first of all, what is it that we want to do? We want to maximize something. Okay, and it says, well, what is it that you want to maximize? You click on select, and you go and select percentage area. Right there. Very good. And now free parameters. The free parameters, remember there were 6 of them. There is this OA, this, alpha, beta, gamma. These are the free parameters. The right here, these are design values, and then we specify the range of them. So for example, if you look at the line OA, you double click on it, it tells you what is the minimum, the maximum, and the steps that it's going to be taken. So this was OA, and if you look at your OA, this was OA. OA goes between 55 and 65. Just a word of caution here, when you put a 55, oops, 55, and what was it? I think 55 and 65, good, and 65, and for steps of 1 millimeter. The next one is AB. AB, 30, and it goes between 30 and 35, 30 and 35. So this is going to be 35. Again, steps of 1 millimeter. Next one is OD. The design value is 60, and OD goes between 65 and 70. 65, is that right? 65 and 70. Yep. So that's going to be 65. Now there is something that I would like to point out here. The 65 and 70. Sometimes what you design for is not in this range that you specify. You're going to get a warning message that this is not in the value that you use is not in that range. Should I proceed? The answer is yes. No problem. Right here, the free parameters is out of range because I believe I use 55 or so. I use 60, and it's not in that range. But that's okay. Don't worry about it. It's updated when needed. Okay. Notice that it did actually move it up. Now you go to the angle alpha between 10 and 15, 1 degree increment. I'm pretty sure it was 10 and 15, yeah. And then 40 and 45 for beta. So beta, 40 and 45. This is where you're going to get that warning that the value that you use is outside of that range. Should it be updated? 1. Oh, maybe it wasn't that range. Was it? What did I use? I can't remember. I used 45, so it wasn't that range. And then gamma between 120 and 140. Okay. Gamma between 120 and 140. And 1 degree increments. Good. One thing you have to make sure that don't you're using simulated annealing algorithm. Fast is fine, and it's the maximum time. Unless necessary, just use default the default, and then you can make changes. Make sure you say save optimization data. Save optimization data, and it's going to let ask you where, and then make sure this is activated with visualization update. So as things are changing, it shows that you're on the screen. Good. Now, you go to under the constraints tab, you say new. What you want is this distance between the two boundaries. You want it to be bigger or equal to. Bigger or equal to, click on the operation. It tells you how you write it, like this, right there. Bigger or equal to 7, right? 7 mm. Make sure you put the mm there, otherwise it's gonna complain because the right, if there is no mm here, 7 has no unit, but the left side dimension of units, so dimension of length. Okay, so we say okay. Yeah, all it says that right now this distance is I think it was 2.3. So just remind you, right? See, actually, right now. Uh, I may come back, and if this doesn't work, I will come back and change my distance and do it a different way. Okay, so let's go ahead to a problem and run optimization. It says where do you want to store it? Remember, this says save data. I'm going to call this thing run 1. I don't like it the way it is right now because it already went through that. I hope that it adjusted and sends it. Oh, yeah, there we are. It did send it up. See, my constraint is not satisfied yet. You can see that it is not satisfied. It says no here. See that? And we're gonna have to fix this. Yeah, that constraint is not satisfied, so we can see this. Okay, so let's go ahead and first of all see what happens here. Let me change this. Let me change this thing because I don't want to spend too much time on this. Let me change this thing to instead of 7. Let me make it I don't know, 5 or something. Run it again. It could be that that constraint, because of the ranges that you put in there, or things will never change. But right now it's satisfied. So bigger than 5. Okay. Uh, with these problems, you have to use your brain, and sometimes what you're asking for can never happen. So you got to be aware of that. So just wait. It's gonna finish soon. Okay. Now, let me select the computation result. Now, it shows you everything, but maybe I should say, okay, just show me the stuff that constraints are satisfied. There we are, okay? For example, let me move this thing on the side, hide the tree, F3, hide the tree. Okay, these are the possible solutions when the constraint is satisfied. So if you look at, for example, this last one, say apply value, add value to the parameters right there. Okay, so we let's try another one. For example, the initial one, which was right here, initial one, apply. See that it changed, but I also want to show you something here, and that is, what is the percentage, by the way? If you look at F3, the tree, we started with, I think, 30%, and now that percentage area is almost 40%. We started with 30, almost 40%. Actually, you can see, if you go back to show me all, the first one, is that the first one? 37, actually it was 37, okay? So, now, let me put this thing back to all constraints are satisfied. Now, show me how the percentage wiped area changed. Okay, so if you look at this, you say select parameters. Show me that percentage wiped area right there. See that percentage wiped area? Show me only this graph and show graph. So basically, we started with some values, and then it reached a bigger percentage wiped area. Now, I don't like this thing because it sure looks like it didn't go far enough to converge. So you may want to rerun this thing under different steps, or let me check something else. So select parameter. Let's show me, for example, the show me OA. Let's see if these things actually, there is a convergence pattern. OA, for example. Show me OA. Okay, that didn't change that much. Let's try something else. Show me angle. How about actually AB, length AB? Oops. Show me length AB. See, these are not changing that much, and I don't like it. I don't like it very much. So what I'm going to do, I'm going to stop the segment here. We'll come back and continue with this, see whether we can do better. Okay. Very good. I'm not perfectly happy with this because I expected the things to look better, but well, let's stop it here, and then on the follow-up segment, I will look into this in more detail.